You stop at a red light. You wait. There are no cars coming from the other direction. The road is empty, and yet, the light doesn't change. It feels random. Sometimes it switches instantly. Other times it keeps you waiting for no clear reason. So what's actually controlling it? Because traffic lights are not just timers. They're part of a hidden system constantly monitoring, calculating, and controlling the flow of entire cities. Most people think traffic lights follow simple timers, that each light changes after a fixed amount of time, over and over again. It seems logical, a predictable cycle, red, yellow, green. But that idea breaks down quickly, because traffic is not predictable. At some moments, roads are empty. At others, they're completely full. If traffic lights worked on fixed timers, cities would constantly be stuck in unnecessary delays. So instead of following a rigid schedule, they adapt. Modern traffic lights are part of a connected system. They don't operate individually. They communicate with sensors, controllers, and sometimes even entire networks across the city. Their goal is simple: keep traffic moving. But achieving that is far more complex than it seems, because every intersection is connected to another, and every decision affects the flow somewhere else. To control traffic, the system first needs to see it. That's where sensors come in. Some are embedded in the road, others use cameras, some even rely on radar or infrared detection. These sensors detect vehicles as they approach intersections. They measure how many cars are waiting, how fast they're moving, and how long they've been stopped. This data is constantly updated in real time. Once the system has data, it makes decisions, but not randomly. Traffic lights use algorithms to determine when to change. If one direction has more cars, it may stay green longer. If another lane is empty, it may skip or shorten that phase entirely. This creates a dynamic system, one that adapts moment by moment. Instead of forcing traffic into a fixed pattern, the real goal isn't just managing one intersection, it's managing flow across the entire city. Traffic lights are coordinated so that vehicles moving along a main road can hit multiple green lights in a row. This is known as a green wave. If timed correctly, traffic keeps moving smoothly without constant stopping. But if disrupted, congestion builds quickly. This coordination happens through centralized systems. Traffic control centers monitor multiple intersections at once. They adjust signals based on real-time conditions. If traffic increases in one area, timing can be changed across several lights. This prevents bottlenecks from spreading, because in a city, one problem can quickly affect everything else. Traffic isn't the same throughout the day. Morning rush hour, afternoon flow, nighttime traffic, each has different patterns. The system adapts to these patterns. During peak hours, more time is given to busy roads. At night, lights may switch faster or even stay green longer if no cars are detected. This reduces unnecessary waiting. Some vehicles get priority. Emergency vehicles like ambulances and fire trucks can override traffic lights. As they approach, signals change to clear the path ahead. Public transport can also receive priority in some cities. This helps buses and trams stay on schedule. The system isn't just about fairness, it's about efficiency. But the system isn't perfect. Sensors can fail. Traffic patterns can change suddenly. Accidents can disrupt entire routes. When that happens, congestion builds fast, and even the most advanced systems struggle to keep up. Because traffic is unpredictable, and cities are constantly changing. Even with automation, humans are still involved. Traffic operators monitor systems in control centers. They intervene when needed, adjust timings, respond to emergencies, manage unusual situations. The system is not fully autonomous. It's a combination of technology and human decision-making. What happens at one intersection is part of something bigger. Entire cities depend on these systems to function. Without them, traffic would quickly collapse into chaos. Because when thousands of vehicles move without coordination, the system breaks down. Traffic lights don't just control intersections. They control the rhythm of a city. So the next time you stop at a red light and it feels like nothing is happening, remember this: that light is part of a system constantly analyzing, predicting, and adjusting in real time. It's not random. It's not simple. It's designed to keep everything moving. Because traffic lights don't just stop cars. They control the flow of entire cities. Not all intersections are the same. Some are simple, with only two directions and minimal traffic, but others are far more complex. They involve multiple lanes, turning points, pedestrian crossings, and sometimes even buses or trams moving through the same space. Each of these elements adds another variable to the system, because it's not just about letting cars pass. It's about deciding which movement should happen first, which one should wait, and how long each phase should last. If one part is mistimed, even by a few seconds, it can create delays that quickly spread across the entire intersection. And when that happens repeatedly, congestion begins to build. Turning lanes make the system even more complicated. Cars don't just move forward, they turn left, turn right, and sometimes cross directly through incoming traffic. Each of these movements has a different impact on flow. In some intersections, turning vehicles are given their own dedicated signal. This allows them to move safely without interfering with other traffic. In other cases, drivers must wait for a gap, which slows everything down. The system has to account for both scenarios, because if turning traffic is not managed properly, it can block entire lanes and create bottlenecks in seconds. Traffic lights don't just control vehicles, they also control people. Pedestrian crossings are built directly into the system. Buttons, timers, and visual signals determine when it's safe to cross. But this process is more calculated than it seems. The system estimates how long it takes for someone to walk across the road. It considers distance, average walking speed, and safety margins. Too little time creates risk. Too much time slows down traffic unnecessarily. So even something as simple as crossing the street is carefully controlled. In many modern cities, the system goes even further. It doesn't just include cars and pedestrians, it also includes cyclists and other forms of micromobility. Bike lanes often have dedicated signals that allow cyclists to move safely. Sometimes entire phases are designed just for them. This reduces conflict between vehicles and bikes, and it creates a smoother, safer flow for everyone, because cities are no longer designed for one type of movement. They are designed for many. To manage all of this complexity, the system needs accurate information, and that's where cameras come in. They don't just capture images, they analyze movement. Some systems can estimate how many vehicles are present. Others can detect changes in speed, sudden stops, or unusual patterns. This allows the system to respond faster and more precisely, because instead of relying on fixed assumptions, it reacts to what is actually happening in real time. Some traffic lights go even further. They don't just react, they learn. Adaptive signal systems analyze patterns over time. They identify which intersections experience congestion and when it happens. Then they adjust signal timing automatically. This means the system improves continuously, without needing constant human intervention. Over time, it becomes more efficient, more responsive, and more accurate. At night, everything changes. Traffic becomes lighter and less predictable. The patterns seen during the day no longer apply, so the system adjusts. In some areas, lights switch faster to reduce waiting times. In others, they stay green until a vehicle is detected. This prevents drivers from sitting at empty intersections. It makes the system feel faster, even when fewer vehicles are on the road. Weather introduces another layer of complexity. Rain slows vehicles down. Fog reduces visibility. Snow can block roads completely. These conditions change how traffic behaves. Drivers react differently. Stopping distances increase. Movement becomes less predictable, so the system has to adapt. Because under these conditions, safety becomes more important than speed. Accidents can disrupt everything instantly. A single blocked lane can reduce the capacity of an entire road. Traffic begins to slow down, then stops, and then spreads outward. This creates a ripple effect. Other intersections are affected, even if they are not directly involved. The system has to respond quickly, adjusting signals, redirecting flow, and reducing pressure in affected areas. Because if it doesn't, the disruption grows. Construction creates similar challenges. Roads are modified, lanes are closed, routes are changed, and traffic patterns shift. Temporary signals may be installed, or existing ones reprogrammed. The system has to remain flexible, because the environment itself is changing. In emergencies, the system behaves differently. Traffic lights can be overridden. Entire routes can be cleared in advance. Signals can be synchronized to create a direct path. This is critical for emergency vehicles, because every second matters, and the system is designed to prioritize speed when it's needed most. Cities are constantly evolving. More people, more vehicles, more demand on the system. What worked years ago may no longer be effective, so traffic systems are continuously updated. New intersections are added, existing ones are optimized, because the system has to grow with the city, and the system is still evolving. In the future, vehicles may communicate directly with traffic lights, sharing data in real time, allowing signals to adjust even more precisely, reducing stops, reducing delays, making traffic flow more smoothly than ever before, because the goal has always been the same: keep everything moving.